Alright, so in this video we go over a new chapter in which we look at hypothesis testing for two populations. So in the previous chapter we did inferences about proportion and the mean of a population based on taking one single sample out of the entire population. However, in this case, we are going to extend this to two samples. So that is, we are going to look at two different sets, basically study the same parameters for the to make inferences about which one is larger than the other, if is larger than the other one sample, or vice versa, or if they are totally different or maybe the same. So the first thing we're going to do in this case is hypothesis testing for two proportions. Well, so in this case, the assumptions that we need to to take into account is that we look for two simple random samples that are independent. For example, if we are going to we're going to determine the mean amount of time people spend, you know, at a shopping center. Well, if we want to compare into those mean times or the proportion from two different cities, well, then we take a sample at one city and then at another city, or maybe in the same city at one mall or at another mall. Depend. So the thing is, none of the samples come from the same sample, from the same population. All right, so let's look at a little bit of proportion. Well, so in this case, we are going to look at P1 and um, P1 and 1, which in this case is the proportion, the population proportion, and 1 is the sample size, and x1 the number of successes in the sample, and P1, this p hat is the sample proportion, just the same, which is like the estimate that we did in the in say in the previous chapter. All right, so so the process is going to be very similar to what we did earlier in the previous chapter. Look at the formula. If you look at this, is very similar. However, it's going to include two proportions. By the way, something that I needed to that is worth mentioning here. Here we are going to have not just P1 but also P2, N2, and X2. Because in this case we are going to look at two different samples. We need two of them. So the formula to find the test statistic will be this P hat, okay, this P hat, P1 hat minus P2 hat, which is the proportion, right? The estimated proportion from the given data. And then we are going to have this P with a bar and Q with a bar. This is what we call the pooled or combined estimate for both of them. And in this case is the sum of both successes divided by the sum of the combined sample sizes. And of course, Q bar is going to be the complement of P1. So I will do only one example using this ugly looking formula. All right, and then I will just show you how to do it using the graphing calculator. All right, so let's look at our first example. So what do we have in here? Well, so a real estate agent claims that the proportion of home ownership in Florida exceeds the proportion of ownership in Maryland. In a sample of 400 Florida residents, 272 were homeowners, and in a sample of 600 Maryland residents, 390 were homeowners. Test this at an alpha equals 0.01 significance. So let's look at this. So we're going to state the p hat 1, which in this case is how about we do some highlights first. Well, so this is going to be x1 over n1, and in this case, this is our x1, and this is our n1. That's the Florida one. And then this is going to be our x2 and n2 right here. All right. And in this case, do we need hats for each? No, we don't need those hats. So, and then x2 over n2. So in this case, what are we going to have here? Well, so 272 out of 400, which is going to give me a 0.68 using a calculator. x2 over n2, that's a 390 divided by 600. And that's going to give us a total of 0.65. Okay. P bar, that's our combined or pooled. That's, let me write down the formula again. Oh, that's just without a bar, x1 plus x2 or n1 plus n2. Okay, let me erase this ugly looking bar. And that's going to be 272 plus 390 divided by 400 plus 600. And if you use a calculator to simplify this, well, you should get 0.662. And of course, that's going to be 1 minus p bar, the q. Q bar is 1 minus 0.662, which is 0.338. All right. Let's state, as usual, what's next? Say the ho, say the ha. So the ho, well, what are we going to get? The null hypothesis. That is the ho. Well, so the proportion of home ownership exceeds the proportion Florida exceeds that of Maryland. Well, that's going to be our alternative hypothesis. All right, so that means Florida, that's P1, and Maryland, that'll be P2. So our alternative hypothesis states that P1 is bigger than P2. Now, when it comes to stating the null hypothesis for two samples, the whole will always be P1 to be equal to P2. I know this doesn't look exactly like the logical opposite as we did in the previous, but in this case, well, that's by default. So the null hypothesis is that both are equal, and with our data we are claiming this. And well, if you look at the numbers, well, Florida, which is P1, 0.68, is bigger than 0.65. Well, clearly, or apparently, right, that indeed exceeds. However, we need statistical evidence. And in this case, well, at an alpha 0.01 significance, well, that's a 99% precision, where alpha 0.01. All right. And in this case, well, let's see what's going to happen here. Well, so again, keep in mind that from the alternative hypothesis, notice I'm highlighting the alternative hypothesis that comes from the sentence I highlighted over here. Look at the direction of the arrow. The arrow is pointing towards the right. That means this is going to be a right-tailed test. All right, so right-tailed test. So we're going to find a C critical here. We'll find out what that is. Don't worry. And that's going to be that. So again, you have two options when it comes to find the Z critical. Well, this is basically 0.99% here. All right, so you can just go ahead and reset. So second distor, either in norm. If you do the 0.01, that's fine. The thing is that you are going to get the negative version. However, it's okay to use that. Just be sure to change the sign to 2 point to positive, and that's going to be 2.33. Again, keep in mind that these scores are rounded to 3 decimal places. Otherwise, do 0.99, and see, you get the same, but now with the opposite sign. All right, so now let's find. Well, let's actually write that down. All right. So in norm of 0.99. And again, I have the 0 and the 1. You can erase those again. Let me show you again. If you delete the comma, the 0, the comma, and the 1, you just do that, boom, you get the same thing here. All right, so we get 2.33. So that's the critical z-score. So again, the criteria is we're going to find the test statistic, and if our statistic value falls within the region, well, we have enough evidence to support our claim, and therefore we reject the whole. Otherwise, fail to reject the whole. All right. So let's see. Let's go about this and calculate the test statistic. Well, this is going to look a little bit painful. Let's see. So Z, which is P with a hat sub 1 minus P2 with a hat minus P1 minus P2 divided by the square root, big root, P bar Q bar divided by N1 plus P bar Q bar divided by N2. All right, that's a bar, that's another bar. All right, so well, one thing to keep in mind. So we know P hat, P1 hat, and P2 hat. We calculated them here. However, what about the difference P1 minus P2? So when we state the null hypothesis, the whole, think of this as an equation. I'm going to move everything to the left-hand side of the equation, and this will become P1 minus P2 equals to 0. So from here, all right, from this part, from this very part right here, okay, this is going to go to 0. And all we do is plug in numbers here and there, and these numbers right there. All right, so what are we going to write? So 0.68 minus 0.65, which is our P1 and P1 hat and P2 hat. All right, and then divide everything by. Notice how I can, in this case, to avoid a lot of avoid a lot of symbols here, I can do P bar Q bar times 1 over N1 plus 1 over N2, because if you notice, these two products are the GCF over here. So what I'm going to do here in this case, P bar Q bar, we found those numbers here. P bar, which is the combined proportion or the pooled proportion, and its complement Q bar. So that's going to be 0.662 times 0.338 times 1/400 plus 1/600. And I'm not going to do every single step here. I'm just going to give you the final answer, because ultimately I'm not going to ask you to do this. I just want to do one example like this, using just so you can see how it's done the long way, and then I'm going to show you how to use all this using the calculator. So I get 0.98 as my test statistic. All right, so now let's see. So our test statistic, which is 0.98, it's a number less than our critical value, that is z equals 0.98. And in this case, do you notice it's falling in the failing to reject the null hypothesis? So what's our conclusion? Well, we failed to reject there is not enough evidence to support our claim. And to find the p-value, okay, do it the same way as we did it before, using the normal CDF of, well, from 0.98 to something big. All right, and let's do this. Okay, so second dister normal CDF, boom, from 0.98 something big, and 0, 1. Ignore the 0 and the 1. You can keep it. You can delete the 0 and the 1. You know, we get same thing. So 1.64. All right, so this is 0.164, which is greater than our alpha value of, which is, what was the alpha value? That's 0.01. Okay, so this is p greater than alpha. So that's the other way to make a conclusion. So yes, if you were doing all this, I don't like this. I mean, it's good to see one example of how do we do this. However, I will show you how to do it using the graphing calculator here. All right, so let's see. South International surveyed 1,181 U.S. adults to gauge the demand of vegetarian meals in restaurants. The study polled 747 men and 434 women. Of those sampled, 176 men and 195 women said that they sometimes order a dish without meat, fish, or fowl I don't know how to pronounce that word, when they eat out. Does the data provide sufficient evidence to conclude that the percentage of U.S. men who sometimes order veg is smaller than the percent of U.S. women who sometimes order veg? Well, use of an alpha 0.05 significance level. Okay, so how are we going to do this? So let's get the data, and let's state the null hypothesis and the the null hypothesis and the alternative hypothesis. So the null hypothesis is that both proportions are the same, right? P1, P2. This one is for men and this is for women. All right. And so the question is, do we have men sometimes order veg is smaller than the amount of women? Okay, so that is, do we have a lesser amount of men ordering a vegetarian dish at a restaurant? Well, let's find out. We're going to do this at a 0.05 significance. That means 95%. Alpha equals 0.05. Well, because of the direction of the inequality sign, well, where is this going to go? To the left. All right. This is going to go to the left. And we're going to find the z critical for 0.05. Okay. In norm. Just going to copy this in norm of second quit. What am I doing? 0.05. Negative 164. That's our z-score here. So negative 1.64. Okay, what are we going to do here? We are going to get these 1, 2, 3 values using the graphing calculator. I actually put a picture of the screen here, which I'm going to show you in a minute how we are going to fill this out. Well, so in this case, x1 and n1 will correspond for the men data, and x2 and 2 for the women data. All right. So what are we going to do? Well, let's go to our graphing calculator, and we are going to go to prop C test. So we're going to go to stat. Then we're going to scroll to the right a couple times where you say the word tests, and go to prop Z test. And just put in the numbers. I have some numbers here. Let me clear everything first. Well, let me put that away. Let me do it by hand first. So x1 is the amount of men that ate a vegetarian dish. In this case, that's 276 out of 747. And for x2 and n2, that's 195 out of 434. And in this case, well, you want to test P1 less than P2. So we are going to choose this option when I show you here. All right, so 276, 747, 195, and 434. And in this case, well, we want the second option to P1 to be less than P2. Click enter. Well, and then, well, whatever the color you want, and then go to calculate. And, well, we are going to have all the data here. So this Z right there is our, well, the critical value we already found it. That's a negative 1.64. Our Z in this case is negative 2.70. And our P value is this little P. Where is my little P right there? That's going to be, where is it? Oh, right there. The first one, 0.003. That's all we do. All right. So let's see. Let's put the stuff together. Negative 2.70. That's somewhere here. That means it falls in the shaded region. So this is going to lead us to conclude that we can reject the null hypothesis. All right. Now, if you compare the p-values, though, well, let's see. Let me put it somewhere here. P and alpha. So P equals 0.003, and alpha, which is 0.05. And in this case, clearly, we have that inequality, okay, which is the reason for which we also reject the null hypothesis. So this is a lot better than doing the tedious and painful calculation using that ugly looking formula. Just put everything in the calculator and select the correct test. Let's do another example. 45 out of 270 females are presently saving in a 401k plan. 56 out of 302 males were saving in a 401k plan. Is the data significant enough to say that the percentage of savers is not the same? Okay, well, what's the ho, what's the ha? The ho, by default, P1 equals to P2. Otherwise, the alternative hypothesis, you are getting data just to say that they are not the same. So P1 not equal to P2. Okay, so this is our number 1. This is our number 2. Write down the numbers. That's all we do. Okay, so 45 out of 270 and 56 out of 302. And in this case, they are not the same. Circle the first option. So number 1, okay, at a 0.01 significance level, well, be careful here. Alpha equals 0.01. That's a 99 precision test. And in this case, well, we need to divide this into 2 evenly spread regions for which alpha over 2 equals 0.005. Alpha over 2 equals 0.005. Okay, that's what we're going to do here. So the z-score critical, okay, let's find the critical value. Okay, let me quit. In norm of 0.05 in this case. And I get 2.58. Both negative, both positive. Negative 2.58 and 2.58. So this is going to be our z critical. Plus minus 2.58, because it's in this case it's a two-tailed test because of the inequality sign in the alternative hypothesis. Let's just put the numbers. Let's go ahead and do that. So stat test to prop z test, and I'm gonna have 45 out of 270, 56 out of 302, and in this case the first option we want this. All right, so let's see, calculate, and our C statistic is going to be negative 0.59, and our p-value is 0.557. In this case, we can easily see that negative 0.59 is in the unshaded region, which in this case leads us to determine that we fail to reject the whole. All right, so we fail in this case. All right, let's do another example. Is this it? Yes. Well, for the next topic, we have a hypothesis testing for two means. In this case, we only do sigma known, and in this case, in which the samples are independent. Well, there's more about this, like having dependent samples, and then there's the other end in which sigma is unknown. But in this case, we're just going to do this one. If we were to use the formula, we would use this huge and nasty looking formula. We're not going to do that. All right, we're not going to do that. So I'm just going to show you how to do it using the graphing calculator. All right, so in this case, let's look at one example. The table below displays salary data from two samples of high school teachers from New Jersey and Delaware. Test the hypothesis that the average teacher salary in New Jersey is more than the average teacher salary in Delaware with alpha 0.05 significance level. So Let's take the whole and the ha. All right. So let's see. So that means that the mean 1 equals mean 2. Otherwise, mean 1 and mean 2, how do we compare those? Well, is more than. All right. That's so New Jersey is M1 and Delaware is going to be mean 2. All right, so let's see. So we're going to do this at an alpha equals 0.01. That means 99% precision. Boom, boom. And in this case, let's see. Oh, wait a minute. Did I say, no, not 0.01, 0.05 rather. So in this case, well, more than, look at the direction of the inequality sign in the alternative hypothesis statement. Well, that's going to be this side. All right, so let's see. All we do, we're given this really nice table for New Jersey and Delaware, the sample mean, so in New Jersey, they sampled 40 teachers, and the mean of their salaries was this value with this standard deviation. They did the same in Delaware, but they sampled 42 high school teachers, and their mean salaries was that. And well, looking at the numbers, well, New Jersey is more than the mean salary in New Jersey is more than that of Delaware. But is that enough evidence? Well, we're going to do statistics to determine whether this data is cool or not. Otherwise, if this is cool, well, we got it. We rejected null hypothesis. Otherwise, this data is just garbage. All right. So let's see. Now we're going to go to two sample z-test, not prop test. So in this case, well, let's put numbers here. So this is going to be a little bit hard to write. Hopefully it doesn't turn out being a mess. Let me get a smaller pen to write this down. Give me a second. So let's see. All right, so sigma 1, so this is sigma 1, this is n1, and this is mu 1. Otherwise, this is mu 2, this is n2, and this is sigma 2. So sigma 1, which is 6812, sigma 2, this is 7514. x1 over n1, well, actually, in this case, it's not mu. It's actually it should be x bar because it's a sample. See that? Careful with your symbols. So x1 is 52,378, and from n1 equals 40. This is 42, and that's 48,773. So it's kind of hard to write it down, so we were going to type it. Let's see. So we're going to go again to stat, test, and that's going to be 2 samp z-test. I mean z-test, yes, the third option. So in this case, let's introduce stats. Notice you will have a option for data or for stats. If you use data, that's when you put all your data in L1 or something, but in this case, we already know the stats. So sigma 1, which will be 6812, sigma 2, which is 7514, x1, which is the mean one of the sample 1, 52,378, and 1 is 40, and x2 is 48,773, and 2, which is 42. All right, which test are we going to do? Well, notice we're going to use the greater than, so go and check this one out. Keep scrolling down and calculate. All right, so we got pretty much everything we need. So the test statistic, which is 2.77, 2.28 rather, and the p-value, which is 0.011. All right, so let's find out what the critical value. I'm going to give it away. That's 1.64. That comes from finding, we have calculated this one many times, but I'm going to do it again just to show you how to do it. Well, it's pretty much this one, right? But the positive version of it. Or else you can do 0.95, 1.64. All right. So in this case, well, 2.28 will fall in the rejection region. That means reject the whole. So we have enough evidence to support our claim. So this data ultimately was not garbage, was good enough to prove this correct, right? All right, let's look at another example, a couple more examples, and let's see. So the table below displays average hotel room rates in Buffalo and Cleveland based on 2 random samples. Test the hypothesis that the average hotel room rate in Buffalo is not equal. What is that going to tell us? It's not equal to the average room rate in Cleveland. That is, the half will be the mu1 is not equal to mu2, and the whole, we assume they are the same. All right. And in this case, we want to test this using an alpha equals 0.05. So in this case, well, it's going to go in 2 different directions. It's going to be a two-tailed test because of the inequality sign. All right, so C critical. Let's see what do we get for Z critical in this case. So let's find in norm of what was it? I think it was 0.025. That's half of negative 1.96. All right. 1.96, negative 1.96. So that's alpha over 2 of 0.025. Alpha over 2, 0.025. Okay, what's going to be next here? Well, critical value plus minus 1.96. Everything here in the unshaded region, we reject the null. We fail to reject the null hypothesis. Otherwise, everything falling in the shaded region, we reject the null hypothesis. So let's go to what was that? Stat test to SAMP C test, the third one, and let's put again. This is x bar 1 and 1 sigma 1, x bar 2 and 2 and sigma 2. All right, let's put these numbers in our graphing calculators. So let's see. Sigma 1, which is 42. Sigma 2, which is 39. I'm not going to put the zeros. They don't mean anything in this case. X1, which is 126.15. And 1, which is 35. And X bar 2, which is 135.6. And N2, which is 46. And then in this case, we want to test that they're not equal. So let's see. Calculate. So our test statistic will be negative 1.03, and our p-value is 0.301, rounding to 3 decimal places. All right. So in this case, well, negative 1.03, it's somewhere here. So in this case, we fail to reject the whole. Now, if we do it the other way around, in this case, this is our P and our alpha. So alpha equals 0.05. And clearly, this is greater than or equal. Actually, the other way around. Greater and great, not just greater. Let me clean this up. So that's the other way to conclude that we fail to reject this. And let's do our last example. So the table below displays the average customer satisfaction data of two similar stores. The scores are average ratings on a scale of 1 to 10. Assume the populations of satisfaction scores are normally distributed. Test the hypothesis that the average customer rating in store A is lower than the average rating in store B with alpha 0.05 significance level. And well, I'm not going. Let's do 95%. That's alpha equals 0.05. And in this case, it's going to be a left-tailed test because lower than, that's ho, ha, the means are the same, or mu1 is less than mu2. All right, that's the number 2. Correct. Critical value 4.05. I think we got it before. Let me quit. It's 1.64. Wait a minute, not 0.1, not 1.64. Wait a minute, give me a second. Where did I get this 1.60? Okay, the 4.05. Did I do it wrong? Never mind. Oh, come on. Yeah, negative 1.64. As usual, shaded region reject the null hypothesis. On shaded region, fail to reject the null hypothesis. So let's put this data on the graphing calculator. That's x bar 1 and sigma 1. X bar 2 and sigma 2. All right, let's go use calculator stat test number 3. That's to SEMC test, and let's put the data right here. So 7.9, and oh no, not 7.9. So the standard deviation is 1.4. The second standard deviation is 1.9. X bar 1, that's 7.9 on 25 people surveyed, and then X bar 2, that's 8.6, and 27 is samples. I said in this case we are going to do a left tail. Select this one. All right. So in this case we get this data. Test statistic negative 1.51, 52 rather, rounding to the correct number, and p-value equals 0.064. So in this case, well, our test statistic indicates 1.64. Our test statistic, look where it's falling, negative 1.52. Negative 1.52. For this reason, we fail to reject. the null hypothesis. And that's all we do. Give it the data, put in the graphing calculator, and go. Give it a go. Now, I'm curious about what happens here. Test to sample seed test. What if I do draw instead of calculate? And well, this is not going to be. Never mind. I need to go delete, and graph. And let me do zoom stat. Hopefully that fixes it. Well, I need to do the test again. One prop z test. No, wait. Do same z test and draw. Let's see what's going to happen. So in this case, it's going to do the left test. Well, in this case, our p-value is typed in here, 0.064, and our test statistic 1.52. That's the other, and this is how we see that this is left-tailed. And in this case, well, if the statistic is somewhere there. Alright, so I think this is a good place to quit. I'll see you on the next video.